Now I request Bhuvana and team from Rajiv Gandhi University of Technological Sciences, Newsbath. Their paper title is Case Study for Application of Sponge City Concept.
I am Ambica and I came from RGKT Newswith IIIT. I was completed my BTech in RGKT Newswith in Civil Engineering Department. And here is our project title, Case Study for Application of Sponge City. And here are the topics which I want to cover in this presentation. Coming to the objective of our presentation, the main reason behind opting this project is water scarcity. Yeah, nowadays water scarcity is very much high in our world itself, and our project mainly focused on one main parameter, that is permeability. Permeability allows the soil, permeability helps the soil to allow the water to pass through into it. And so our project mainly focused on permeability, and after conducting that test on a soil, we have concluded that whether the type of soil needs a concept like spongicity or not. And coming to the definition of a sponge city, it is a city that has a capacity to mainstream the urban water management into urban water policies and designs. And sponge city has a different components like detention ponds, green roofs, and parks and plantations, constructed wetlands and whatnot. All these are included in this sponge city. And I really wanted to say some facts that some new initiatives that upon the water, that is one of those initiatives was Nimble Vision. It is an initiative which was done with the help of IoT, Internet of Things. It is a new technology. And by using that, they made a meter which helps to automatically on and off the overhead tank motor, so that water wastage will be low in that. And also second initiative was waterless cleaning technology. It mainly focused on cleaning for cleaning purpose we are using more and more water. So for that they came up with a new alternative. Why I am saying this, these all initiatives means we also worked on a new initiative, that is sponge city concept. It mainly focused on how to store the water, how to save the water, and also how to prevent the droughts and floods. Please slide. Before doing the experiments or before doing our project, we have gone through some literature reviews. We have gone through some research papers. Like in that first paper, they proposed that what are the problems involved in the water, and what are the management issues that involved in a sponge city construction. And in a second paper, they have proposed about the solutions to these problems, and they were also mainly focused on stormwater management. And in a third paper, they have proposed about planning, design, and construction of a sponge city concept. They have used the content analysis method to analyze that. And in a fourth paper, they have used scientometric analysis to analyze the sponge city concept. And in all those, we have read many research papers, and we have thought that there is a research gap. That is, they are applying this sponge city concept only when the drought or a flood is occurring. So what we have done is, we have taken some soil samples in our college premises, and we have conducted several tests and also permeability. And based upon that result, we have concluded that not only in the drought and flood-prone area we can apply this concept. In all other areas also we can apply this concept. Methodology we have followed. First, we have understand the sponge city concept by reading many research papers, and after that we have collected different soil samples in our college premises based on our elevation. And also we have, after that we have conducted several laboratory tests like moisture content, specific gravity, sieve analysis, and permeability. Why we have conducted all these tests means permeability permeability have effect, these all parameters affects the permeability. So we have done all these experiments. And after, based on a permeability, we have classified the soil, and also we have classified that whether that.
What are the problems you have faced during the testing of the soil in respect to laboratory in terms of to testing the moisture content and the specific gravity and like this? So such kind of parameters are measured using a respect to testing tools at a particular laboratory. What are the problems you have faced?
Moisture changes, and we have to collect that samples from a field, and then we have to shift that samples to the laboratory. In this time period, we have observed that moisture is changing, and also temperature changes. So we cannot get the accurate results. That's all.
Any relationship between moisture content and permeability?
As moisture content increases, permeability decreases, sir. Because
what do you mean by permeability?
Permeability, which helps the soil to allow the water to pass through it, sir.
Allow the water molecules passing through it. That is the permeability. How to express the permeability number by using a soil? Permeability number.
Permeability number.
You don't know?
It will be denoted as K, sir. It has several values.
How much is specific gravity maintained with respect to using a soil?
Specific gravity, 2.65 to 2.85, sir, generally, but we have got 2.4 to 2.85.
So exceeding a unity, more than unity.
Yes, sir.
This is the unique feature of a soil.
Yes,
so that is the best fit for that to construct the civil engineering works. Right. What do you mean by specific gravity?
It is a relative density, sir.
Yes, comparative density, relative density, the ratio of
density of a soil by
density of the particles to density of standard reference fluid or water.
Yes.
That is specific gravity. Good.
Next slide. Next slide. Okay, sir. Here is a working model of a sponsity. Here they used the permeable pavements and detention ponds and parks, green roofs, etc. Every drop will be collected by these components of the sponsity, and they are percolated into the soil. And another one is the main important component in the sponsity is a drain system. How effective the drains are interlinked, or we have to separate the sanitary sewer and also the stormwater sewer, and based upon that, when we do the treatment, then it will be efficient. Here are the locations of soil samples we have collected in our college, and they are the laboratory tests we have conducted on the soil samples. Moisture content. Moisture content is inversely proportional to the permeability value. As the pores filled with the water, there will be no pores to fill the further water. So permeability automatically decreases. Here is the formula and the results. As we see, the moisture content is less for that sample 1. Here are the observations we have done in our laboratory. Next. And it is a specific gravity. We have conducted one more test called specific gravity. It is also termed as a relative density. It is also inversely proportional to the permeability, because it is a ratio between density of a soil and the density of a water. As the density of a soil increases, then automatically permeability decreases, because pores are filled with the soil, so there will be no way for the water to pass through it. So permeability automatically decreases. Here are the observations we have done. We have
the space between water molecule to another adjacent water molecule for given particular selected volume. Okay, the space is more. The occupation of the water molecules are less. The total entire density of the selected volume of the water values increase or decrease. Are you following? Are you able to understand my point? Are you able to receiving my question? The distance between molecule to molecule is more. The density of molecule is more or less?
Maybe I think less.
Less. Why?
Because spaces are more and the water molecule is less, so density automatically decreases.
So mass of the water molecule is less? weight decrease, density also decrease because of water molecule
is less.
packing is very less. Yes.
Next. And here is a sieve analysis. We have classified the soil based upon a coefficient of curvature and coefficient of uniformity. And here is the graph. We have classified that whether the type of soil is well-graded gravel or sand or something. It is a standard Proctor test. We have done this test to. I'll do. We have conducted this test to obtain the maximum maximum dry density and optimum moisture content. Only we have used this optimum moisture content value in a permeability test. So for that purpose only we have done this test. That's all. And coming to the permeability, it is the main important parameter. And here is the formula for that, and also the specifications. Also we have provided. It will be measured in centimeter per second. Yeah. We have conducted the permeability test on a soil at 0% moisture content and at also optimum moisture content. Here are the graphs. This graph is drawn between the location and also coefficient of permeability. We have just drawn this graph to simply identify at which location the permeability is more. If the permeability is rapid, then no need to apply any spongicity concept or anything. So we have tabulated the results. Only the two soil samples got the rapid permeability, so there is no need to apply any spongicity concept. And remaining in all other locations, we have to apply the spongicity concept because it is moderate. In our college premises, there is no impermeable soil strata. Here are the results. We have conducted the tests like sieve analysis, compaction test, and specific gravity, permeability, and moisture content. And only sample 2 and 7 got the rapid permeability, so there is no need to apply any spongicity concept. And the sample locations at where we got the moderate, then there is a need to apply this, like the components like green roofs, constructed wetlands, and plantations. Why I am stressing the plantations means when we grow a crop or a plant, then it loses the soil. When it loses the soil, there is a way to the water to pass through it. So plantations helps the soil to become permeable. Here are the total results of our project, and we can see when the moisture content is less than 15%, then it will be classified as very dry soil, and the moisture content in between 15 to 20%, then it will be classified as dry soil, and 20 to 25%, then it will be classified as wet soil, and greater than 30%, it will be classified as very wet soil. And specific gravity, it should be in a range of 2.65 to 2.85, but due to the moisture and temperature changes, we have got 2.4 to 2.85. And optimum moisture content in sample number 7 and 8 got 14% optimum moisture content. We have conducted this test for only comparison purpose. I mean permeability variation according to the moisture content, we have to observe that. So for that only we have conducted this test. And coefficient, coming to the coefficient of permeability test, based upon the results we get, we have classified them into rapid and moderate permeability. And after that, in the last column, we have concluded whether that particular soil needs a spongicity or not. Conclusion is itself. Future scope. According to the government data, 57% of drought-prone areas were increased since 1997, and nearly 2/3 of the country suffered from droughts from 2022 to 2022. And even the United Nations Convention to combat the drought also mainly focused on drought. So all these recent happenings are indicating the future water scarcity. So the concepts like spongicity are really wanted or needed for the current world now. And thank you for giving this great opportunity, and thanks for the RISE. Thanks a lot.